Hello guys, welcome to our today's presentation. I'm very happy to have you in this channel. Today I'm going to introduce something under calculus, and the part is differentiation and its application. So in this our lesson we are going to get to learn on how we can work out the equation of the normal, and at the same time we are going to work out the coordinates for the turning points, coordinate for the turning point by the end of this presentation. So stay around. If you are new, feel free to subscribe to this channel. This is what we do in this channel, and be part of this growing family. Welcome, and let us learn and earn together. Now, the equation of a curve is given by y is equals to 3, y is equals to 3x squared minus 2x. We are supposed to determine the equation of a normal, sorry, of a normal to the curve, the equation of a normal to the curve. That is what we are supposed to do. Now, for us to be able to get this right, we need to remember something we learned under differentiation. Now, the first thing we are going to do, we have to write our equation down and say that the equation is y is equals to 3x squared minus 2x. So we want to first of all work out the gradient. And how do we find the gradient? The gradient is given by the dy over dx, change in y over change in x. That one will give us the gradient. Now let us differentiate this equation. When we differentiate the power, we are going to multiply the power by the value we have here, the value that is coming before x. So we are going to multiply 2 by what? By 3, and we are going to reduce the power by 1. So we end up having 3, we multiply by 2, then we are going to reduce the power to 1. Now this one is to power 1, which is the same as x. Then we take away, of course, this is the same as 1. When you multiply by -2, you will have -2 like this. So we are going to have our dy over dx as 6x and then minus 2. Now in this case, for us to be able to work out the gradient, then we will have to remember at the point that says that we have got the x coordinate, which is positive 2. Now x is equals to 2. Now our gradient is going to be complete if we substitute this 2 into x. Now we are going to say 6. When you substitute this, you multiply by 2, then you take away 2. You're going to have 12, you take away 2. This one is going to give us 10. So our first gradient, or our M1 is in fact 10. So this is our M1, or in other words, gradient 1. So any time we are dealing with the equation of a normal to the curve, we need to remember the concept of perpendicular lines. This is the concept of perpendicular lines, and we all know that M1 times M2 under perpendicular lines, it will give us -1. So the first gradient you multiply by the second gradient, you're going to get the product of -1. Now that we have got our M1, we are going to substitute and say it is 10 M2 is equals to -1. We divide both sides by 10. We divide by 10. So our m2 is going to be -1/10. Our m2 is -1/10. -1/10. So this is our m2. Now the next thing that we are interested in is the coordinate for y. We already have the coordinate for x, so we must obtain that one for y so that we'll be able to work out that equation. Now let us go back to our equation that says y is equals to 3x squared minus 2x, but we've been told that x is equals to 2. So where we see x, we replace that by 2. So our coordinate for y is going to be, or our value for y is going to be 3. We multiply by 2 squared. Then we take away 2, we multiply by 2. So 2 squared is 4. We are going to have a product of 12. Then we take away 4. 12, we take away 4. If we do that, then surely we are going to get the value of y as +8. So y is +8. So the coordinate that is very important to us is, in fact, or the point that is very important to us is this point with the following coordinate: x as 2, then y as 8. Now we can proceed and work out the equation of the normal by saying, for us to get the equation, it is the change in y or over the change in x. The change in x, this one we equate to the second gradient that we obtained, m2. Now what is the change in y? We are going to have our y, then we take away 8, and then we divide by our x, we take away 2, then we equate to -1/10. We do cross multiplication like this, then we shall have 10y minus 80 is equals to -x, then plus 2. Now we put like terms together. In this case, we want to put the like terms together. Let us use the other side. We put the like terms together by saying that we are going to say that what we have is, in fact, 10y minus 80 is equals to -x plus 2. 10y is equals to -x plus 2. Then this is a negative. When it goes to the other side, it becomes a positive 80. So we say 10y is equals to -x, then plus 82. We divide both sides by 10. We divide both sides by 10. So these 10 and 10 will cancel. We end up having y as y is equals to -1/10x, then plus 2 goes here 5 times, 2 goes here 41 times. Now we can go ahead and say we simplify this and say if we have 8, we multiply by 5, we are going to get 40. Then plus 1, of course, we are going to get 41. Our final answer is going to look like this, and we have formed the equation of the normal to the curve. This is the equation of the normal to the curve. Remember, anytime you are dealing with the normal to the curve, that is the same as saying perpendicular. So remember, under the equation of a straight line in form 2, we said that the product of the gradient of perpendicular lines is equals to negative 1. So that is the main concept that is required in this whole operation. Now, let us proceed to our second equation. The second question that is very important to us. It is a 10 mark question, and it is very easy. I want to put these things very clear to us. The question reads, the gradient of the curve y is equals to x raised to power 3 plus 5x squared plus px minus 18 at x is equals to negative 1. The gradient is negative 15. So we are supposed to work out the value of p. That is for part, sorry, that is for part, that is for part, part 1. Now, let us write down the information that is very important to us. And the information, we have to say that y is equals to x raised to power 3 plus 5x squared plus px minus 18. This is the equation. Now, we have been told that the gradient of this equation, the gradient of this curve is going to be negative 15 at a point which is negative 1. For us to get the gradient, we need to remember that the change in y over change in x is the one that is going to give us the gradient. And what is the change in y or over the change in x? We are going to differentiate the y by saying that we have now 3x squared plus 10x now plus p. This one must give you negative 15. So we are going to say that our 3x squared plus 10x plus p is going to give us negative 15. For us to be able to obtain the gradient, we'll have to remember that this gradient was obtained at a point, and the point is negative 1. So where we see x, we substitute by negative 1. Now we are going to say that 3 into negative 1 squared plus 10 into negative 1 plus p. This one is going to give us negative 15. Negative 1 squared is positive 1, so this is 3 minus 10 plus p is equals to negative 15. And now what is 3? You take away 10, it's negative 7 plus p is equals to negative 15. We put like terms together. P is going to be a negative 15 plus 7. Now our final value for p is going to be negative 8. Our final value for p is going to be negative 8. Very well. We are done with part our Roman 1. What about Roman 2? The equation of the normal to the curve. Remember from from my previous utterances, I said that anytime normal is mentioned, we need to know that the product of the gradients of the two gradients will give you negative 1. Now, let us rewrite the equation. Now that we have the value of p, let us write the whole equation. Y is equals to x raised to power 3 plus 5x squared. Now instead of p, our p was negative 8. We are going to say negative 8x, then minus 18. Now this is the complete equation, Now, let us get the change in y over the change in x. The change in y over the change in x. The change in y over change in x is going to be 3x squared plus 5x minus 8. Now, for us to be able to get the gradient at the negative 1, we are going to say that the value of x is going to be negative 1 from the question. Now, at this point, the gradient is going to be, where we see x, we replace that with negative 1. So we are going to have 3 into negative 1 squared plus 5 into negative 1, and then minus 8. So our 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 gradient is going to be, this is 3 minus 5, then minus 8. This is going to be negative 15. We were given this information. I just wanted to show us how they arrived at this negative 15. From the introductory part of this question, they said that at point x, which is negative 1, the gradient is negative 15. So I just wanted to show us how they arrived at this negative 15. Now let us proceed to the equation. Now that we have our m1 as negative 15, remember m1 is negative 15, and we all know that m1 times m2 for perpendicular lines is going to give us negative 1. Now, negative 15 is our m1. What about m2? We divide both sides by negative 15 by negative 15. So our m2 is going to be positive 1 over 15, positive 1 over 15, positive 1 over 15. Now that we have got our m2, the next thing we want to work out the value of y for us to have a coordinate, a point, a complete point with x and y values. Now, we will have to go back again to the equation and say we now have been given we already know the value of x. What about y? We say y now is going to be x raised to power 3 plus 5x squared minus 8x, then minus 18. We already know what x is, so ours is to substitute x negative 1 raised to power 3 plus 5 into negative 1 squared minus 8 into negative 1, then minus 18. If you put this in a calculator, you put this in a calculator, I'm very sure that we are going to arrive at this is negative 1, and this is positive 5, and then we have positive 8, then negative 18. So this is 4, this is 4, 4 plus 8, 12, 12 minus 18. So our y is going to be negative 6. Our y is going to be negative 6. Now, if y is negative 6, now the point, let us complete the point. We are going to say that the point is going to be negative 1, comma negative 6. Now the point is complete. Now let us proceed and work out the equation of the normal to the curve by saying it is given by the change in y over the change in x, and this time round we are going to equate to the second gradient. This means that y is going to be y, because these are negative, minus going to be positive 6, and then x minus 1 is going to be positive 1, is equals to 1 over 15. We cross multiply, we will have 15y is then plus this is 90 is equals to x plus 1. Put like terms together, 15y is equals to x. Now this is 90. When it goes to the other side, it is a negative. So 1 minus 90 is going to be negative 89. We divide both sides by 15. We divide by 15 by 15. 15 and 15 will cancel. Now our final answer is going to be y is equals to 1 over 15 1 over 15x, then you take away. This is now going to be 15. If you multiply by 5, we are going to get 75. Now 75, 89, you take away 75, we remain with 14. So this is our answer. That is the equation of the normal to the curve. The equation of the normal to the curve. This is the one that we were supposed to work out. Now, the last part of this question, it is very interesting. It is very interesting. This part is very interesting. And how is it interesting? We are going to see that in a few minutes. The second part of this question, or part B, reads find the coordinates of the turning point of the turning points of the curve. We need to remember that at the turning point, let us say this, that at the turning point, the gradient dy dx is going to be 0. The gradient is going to be 0. Now, change in y over change in x is going to be 0. Now, what is our dy over dx? Our dy over dx is in fact 3x squared plus 10x then minus 8 from the equation. How have I obtained this? This is the equation that we have. Remember, our complete equation was y is equals to x raised to power 3, then plus 5x squared, then minus 8x minus 18. If you differentiate this, you are going to get 3x squared plus 10x and then minus 8. That is what I have obtained from that part. Let us proceed. Now that we have our dy over dx as 3x squared plus 10x minus 8, this is a quadratic equation, and this time round we are going to use a product sum factor method to help us get the two values for what? For x. Now, what is the product? The product is negative 24x squared. What about the sum? The sum is 10x. And the factors, we are going to have, the first one is negative 2x, and the second one is 12x. If you multiply the two, you are going to get the product, and if you add them, you will surely get positive 10. Now, 3x squared minus 2x, then 12x minus 8. In the first bracket, the common factor is x. You multiply x by 3x minus 2, you are going to arrive at what we have up here. Now, the second bracket, the common factor is 4. If you multiply by 3x minus 2, you are going to obtain what we have here. Now that the two brackets are similar, we take one by saying x plus 4. You multiply this by 3x minus 2. This one must give you 0. Now, our first value for x is going to be x is equals to negative 4. Or somebody can say x is equals to, from this bracket, when you take x to the other side, so positive 2, and then you divide by 3, x is goes to 2 over 3. 2 over 3. Very important. Now, we already have two values for x. Now, what is remaining is to get the two values for y. Now, at x is equals to negative 4, y is going to be, we want to substitute we want to substitute what we have been given. Now where we see x, we substitute by -4 in the main equation. Remember, the main equation was x raised to power 3 plus 5x squared minus 8x, then minus 18. Now, where we see x, we replace with the -4. So -4 raised to power 3 plus 5 into -4 squared minus 8 into -4, then minus 18. This one is going to give us, this is -64, then plus, this is going to be 16 by 5, 80, then plus this is 32, then minus 18. Then we are going to get this is -16 plus 12, and plus 32 minus 16. This is going to give us positive 30. Positive 30. If you insert this in your calculator, I'm very sure that you will arrive at you are going to arrive at positive 30, if I'm not wrong. Yes, this is negative no, this is positive 16. 16 plus 32, it will give us 48, minus 18, we have 30. We have 30. Now, at x is equals to positive 2 over 3, y is going to be 2 over 3. We raise this to power 3 plus 5 into 2 over 3. We square this, then minus 8 into 2 over 3, then minus 18. This one is going to give us, I'm very sure that this one is going to give us 8 over 27. Now plus this is 20 over this is 9, then minus 16 over 3, then minus 18. If you find the LCM is 27. Now 27 is the LCM. This one goes here once, 8 plus 3 i's, this is 60, minus 3 goes here 9 times, you multiply 144, you get 144, minus this goes here once, 486. Now if you work out this mathematics very well, you are going to get negative 562 over 27. If you simplify this further, you are going to get 27. You multiply by 20, then the remaining number, or the remaining value, is in fact 22. Negative, of course, is supposed to be here. Now the coordinates for the turning points, there are 2 and they must be 2. The coordinates for the turning point, are 2. So we are going to say that turning points are, now the first one is in fact -4, 30. That is the first one. And the second one, which is 2 over 3, -20, 22 over 27. So this is how we work out the coordinates for the turning points. Thank you so much. Until we meet again in our next presentation, share this video and ensure that you leave a comment for me. Thank you so much.